Hello everyone, this question has been taken from Olympiad Pathfinder, multiple choice question number 34, chapter 2. Question is, in the arrangement zone, the springs are light and have stiffness K1 is equal to 100 Newton meter per meter and K2 is equal to 200 Newton per meter. And the pulleys are ideal. So ideal pulleys means massless and frictionless. Springs are light means no weight, no mass. An 8 kg block suspended from the lower pulley is initially held at rest, maintaining the string straight and spring relaxed. So this M is initially supported in such a condition that spring is relaxed, no extension. Okay. And string is straight. And so it is not under tension, but it is straight. Now the force supporting the block is gradually reduced to zero. The force supporting the block is gradually reducing to zero. So it means the block will start coming down, 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 down. And gradually means all the time supporting force is reducing in such a way so that the system is in equilibrium. Okay. Acceleration due to gravity to be taken as 10 meter per second square. Then it is asking how far does the block descend during the process of reduction of the force. So let us discuss and solve it. I have given the write-up over here, you can go through. So as per the questions, the block M is lowered gradually. It means the system is all the time in equilibrium till the time the supporting force reduces to zero. So spring with stiffness K1 is connected with the light thread from here to here. Therefore, tension in the thread will be equal to the extension, equal to the force due to spring arising due to extension in it, that is x1. So T1 is equal to K1 x1. Similarly, if we assume that extension in spring 2 is x2, then the tension in the string attached to spring K2 will be equal to K2 x2. Now let us make the free body diagram of pulley 1. This is your pulley 1. I have marked it as 1 and this is as 2, right? So here is the thread. So tension is equal to K1 x1. Here also K1 x1. And in this string the tension is K2 x2, right? So from this diagram you can write the equation of motion. So K2 x2 is equal to 2 K1 x1. So x2 will be equal to x1. When you put the value of K2, okay, in the terms of K1, because K2 is double the value of K1, so you will get x2 is equal to x1. Means extension in x1, extension in spring 1 and spring 2 will be same in this situation. Now we will make the free body diagram of pulley 2. This one is the pulley 2 with the mass. So K2 x2 acting here, K2 x2 is acting here, right? And on this system, mg is acting downwards, right? Because this we have taken it as a system, right? So here it is K2 x2, K2 x2 is fine, and here is the external force which is mg acting on the mass, right? So 2 K2 x2 will be equal to mg. So x2 will be mg by 2 k2, and when you put the value, we will get 1 by 5 meter. So x2 is equal to x1 will be equal to 1 by 5 meter. Now we have to calculate that how far this M has come down due to extension in spring 1 and extension in spring 2. So for easy understanding, first we consider the drop of pulley 1, that how much the pulley 1 came down due to extension in x1. So if this spring is extending by x1, means x1 by 2 will come down here and x1 by 2 will come down here, means pulley will go down by x1 by 2. Sorry. If the pulley 1 is down by x1 by 2, now when the pulley 1 is going down by x1 by 2, so what will happen? X1 by 4 and x1 by 4 from this side, the pulley 2 will go down. So this is shown here. So if the extension in the spring 2 is x2, so that we have taken, right? And we had calculated from the Newton's law of motion that x2 is equal to x1 in this case. So the pulley will go down by due to extension in spring x2. See, it will go down by x2 by 2 from this side, x2 by 2 from this side, right? Because total extension is x2, so x2 will be divided on two sides, right? So x2 by 2. But you can see that extension of x2 does not have any effect on extension on x1 now, because x1 is already happened. So now when it is slackening down, so it will be going down, the string will be loosening and it will be wrapping on this pulley. So x2 by 2, overall the displacement of this pulley will be x2 by 2 due to this extension x2. Now we superimpose these two motions. Movement of pulley 2. One due to spring 1 and other due to spring 2. So overall movement of pulley 2 will be x1 by 4 plus x2 by 2. And from the diagram it is clear that the displacement of the pulley will be same as that of the mass, because the mass is attached directly to the axle of the pulley. So overall drop in this block will be x1 by 4 plus x2 by 2. Now put the value of x2 and x1 in this equation. So 3 by 20 meter is equal to 15 centimeters. If you go and check in the options, option B is showing 15 centimeters. So our option B is correct. So hopefully you understood the concept of solving it. In case of any doubt, please do write in the comment box. Thank you.